In this lesson, we're going to talk about import statements, modules, and packages. In the previous lessons, we've actually seen and used 3 different import statements already. For example, we had import pandas as pd, we had import matplotlib.pyplot as plt, and we also had from sklearn.linearmodel import linear regression. These are the 3 import statements that we're going to talk about in detail in this video. Each of these import statements imports a Python module that we can then use in our Jupyter notebook. If you've already got some experience in programming, perhaps in other languages, the easiest way to think about Python modules is as frameworks or as libraries. This is what they're going to be called in other languages. That said, the simplest way to think about a Python module is that every file that ends in .py is a Python module. And by importing a module, we get access to the variables and the functions inside the file that was imported. In other words, importing gives us access to a .py file's contents. Now, so far, we actually haven't seen any files with a .py extension. And why should a file end in .py in the first place? Well, a .py file is a file that contains Python code. And to see how this all works, we're going to create a file with a .py extension together. To do that, we're going to open a text editor. In fact, every Windows machine comes with a default text editor pre-installed. That text editor's name is Notepad, and it looks like this. Now, you're probably not going to have the shortcut on your taskbar, so go to your Start menu, and then go to find all your programs and search for Notepad, and you should also find it. And remember, not Microsoft Word, Notepad. That's what we're going with. If you have a Windows machine, then open Notepad now. Now, on the other hand, if you're on Mac, the default text editor that you've got pre-installed is called TextEdit. And you can find this program in your Applications folder. So open this program now and create a new document. If your new document looks like this, then go to Format and click on Make Plain Text. This is what you want your text editor to look like for the next steps. Now, of course, there are lots of other, and some might say superior, text editors available too. My current favorite is actually called Atom, and this is made by the team behind the GitHub website. I've included the link to atom.io in the lesson resources if you want to download it. It's available for both Windows and for Mac, and once you start using it, you'll never go back to Notepad again, I promise. Now that you've got your text editor open, create a variable called the answer and set it equal to the number 42. Then go to File and click Save As. Now navigate to your desktop, and instead of saving this file with a .txt extension, what we're going to do is we're going to call it life and then append a .py extension. This is because we want to save a .py file. The important thing on Windows is that you have to change the save as file type from text documents.txt, right, to this other item in the dropdown. You want to change it to all files. And only then can you click Save. After you've done that, check your desktop to make sure that the file that you saved really does read .py at the end, and not something else like .py.txt, okay? This is what we're looking for, life.py. Now, if you're on Mac and you're using TextEdit, we're going to do the very same thing as the Windows crew. We're going to create a variable called the answer and set it equal to 42, and then we're going to go to Save. You're also going to go to Desktop, and then you should be able to name your file life and give it the extension .py. Now, before you click save, just double check that it says plain text encoding Unicode down here. If it says something else like rich text, you haven't gone to format and made the file plain text. So after you've verified this, just click save, and then you can quit your text editor and verify that there is indeed a life.py file on your desktop. And just like that, we've created our first Python script file. Now let's upload this file to our Jupyter notebook. Go to your ML projects folder in Jupyter and click upload. Then navigate to your desktop where you've saved your file, choose it, and click open. And then afterwards, confirm your upload here. If you've been successful, you should be able to click on this .py file and verify that it says the answer equals 42. Jupyter Notebook will open this in a new tab for you. The exciting thing is that now that we've uploaded our Python script as a .py file to our project folder, we can start using it in our Jupyter Notebook. Check this out. Back in our Python intro Jupyter Notebook, we can write import life and hit Shift-Enter. If you see no error messages at this point, the import was successful. Now, because I have an irrational love of data types, let's check out what the type of this thing called life actually is. I'm going to write type and put life between the parentheses and hit Shift-Enter. Aha! So here we find out that our life.py file, when we import it, is called a module. Now here comes the really cool part. We're going to access the code inside our life module. Write life.theAnswer and hit Shift-Enter. Now remember, what we see now is the value inside our theAnswer variable that is shown below the cell. How cool is that? I think this is super cool. It's like our Jupyter Notebook has made a new friend. But let's take a second to think about what this line of code actually means. It literally means fetch the value of the name, the answer, that lives inside the module called life. The thing to note here is the Python syntax. We've accessed the variable inside the life.py file using the dot notation. We've accessed the answer by writing life.theAnswer. And this notation will come up again and again as we progress throughout the course. Okay, so now that we've just uploaded our own file and then imported it into our notebook, let's draw a link to the previous lessons. Now, you'll probably remember that to import pandas, we didn't have to upload any .py files. We just wrote import pandas, and then it just worked. How is it that we can actually do that? See, I used to think it was magic, but then sadly I discovered that it was not, in fact, magic. It turns out that when we installed Anaconda, a whole bunch of modules were already included in our installation. And this is why there was no need to upload any pandas.py file to our projects folder. Jupyter Notebook already knew about pandas, and we could just write import pandas. But this should make you suspicious, right? It begs the question, what kind of other stuff does Jupyter already know about? So let's take a look together at what modules we have access to out of the box from installing Python Anaconda. We can get hold of this information in various places. The first place that we're going to check is the Anaconda Navigator. When you open the Anaconda Navigator, you'll notice that on the left you have this tab called Environments. And when you click on it, under Root, you get a long list of all the modules that you have access to. We can even filter on installed versus not installed. And we can also filter by name. So if I type in pandas, I can see that there's a check mark next to it. So pandas is one of the installed modules, which means that we can access it easily by writing an import statement. Now these filters in the Anaconda Navigator are actually super handy because we can quickly figure out if something was installed or not installed. But if we look closely at this window, you'll notice that it's not referring to the items in this list as modules. Instead, it's referring to them as packages. And it says I've got 195 packages available. And this brings me to my next point. When we were writing our import statements and we looked at the type of thing that we imported, it was called a module. However, when people talk about pandas or scikit-learn, they'll use another word. They'll use this word package, just like the Anaconda Navigator. Even on the Anaconda website, they talk about Anaconda having 1,000 plus data science packages. Since you and I both installed Anaconda on our own computers, we can actually see what these packages actually look like. Because pandas has to live somewhere on our hard drive after all, right? I mean, don't tell the World Wildlife Fund, but you and I are now going to go on a hunt for pandas. When we installed Anaconda on our own machine, it will have created a folder somewhere. On a Mac, that folder will be under your home folder. So we can go to Go, Home, and then get taken to our home folder. There, we'll have a folder called Anaconda. And then inside the Anaconda folder, with all the Anaconda related stuff, we have a folder called PKGS. PKGS, of course, stands for packages. On Windows, that Anaconda folder will be hiding elsewhere. So you'll have to go to your local disk. This will probably be your C drive. And then you'll have to go to Users. Then you'll have to go to your account. So mine's called PD. And inside there, you'll have a folder called Anaconda 3. Once inside your Anaconda folder, you're going to have to venture deeper to find the pandas. You've got to open your lib folder, and then you'll have to open the site packages folder. And there you're going to get the list of all the packages that came with Anaconda once you installed it. Now this is exactly the same list that you saw in the Anaconda Navigator. And looking at this list, you'll probably realize that even though the Anaconda team brags about 1,000 plus packages in Anaconda, we're actually super lucky that by default it doesn't install all of them on the machine from the get-go. So now that we've successfully hunted down our pandas folder, let's return to the original question. Why is pandas referred to as a package? Well, as you can see, when we look inside the pandas directory, pandas is not a single .py file. Instead, pandas is actually a whole bunch of .py files that are grouped together into a single bundle. In other words, a package is just a collection of files. And when we refer to pandas as a package, we're referring to this bundle of files that is living on our computer. Because, after all, the sad fact of life is that there just isn't any magic. And to be honest, we don't actually deeply care about what all of these individual files do exactly. That's all under the hood, but I wanted to show it to you guys nonetheless. At the end of the day, all we need is an easy way to refer to all of this code inside this pandas directory. And this brings us full circle to the Jupyter Notebook, because our Python code with that one import statement allows us to gain access to all the files in that pandas directory with a single line of code. But this story doesn't end here. The packages that we downloaded as part of Anaconda aren't the only modules that we have access to actually. Some modules are built into the Python language itself. And these built-in modules include everything on this list. This list is the so-called standard library, and there are over 200 modules here, so it's a pretty massive list. Scrolling around on here, we see that there's one module called math. Let's take a closer look at this math module. The math module is something that we can use to do all sorts of calculations. And this module actually has information on two things, namely the value of pi and the number e. So as a challenge, as an exercise, can you import the math module into your Jupyter Notebook? And after you've imported the math module, can you write the Python code to print out the value of pi below the cell, and then after that, write some more code to print out the value of e as well? I'll give you a few seconds to figure this out and pause the video. And here's the solution. And just like we've imported pandas, we simply write import math. And to show the value of pi below the cell, I can write math.pi and hit Shift Enter. And there it is. There's the value of pi as per the math module. And looking at the official Python documentation, we can see that we can access the value of e using this code right here. In our Jupyter notebook, this means that I can simply write math.e and hit Shift Enter to complete the final part of the challenge. So that's pretty cool, right? Using the module and the dot notation, we can access any of the variables inside the module through their name. This is exactly the same syntax that we used when we uploaded our own .py file and accessed the answer by writing life.theanswer. And this goes to show that we can access a lot of code from other modules like the math module using the same dot notation. Now let's take another look at this pandas import statement. Because this import statement that we wrote with pandas was a little more complex than the one we wrote with import math or import life. The pandas import statement had something a little extra. We wrote import pandas as PD. And Jupyter is highlighting the as in green. So the syntax highlighting is telling us that the as in the line is a Python keyword. So what does this as PD part do? Why is it in there? If you remember, we actually saw this pattern again with the other import statement that we used further down. Import matplotlib.pyplot as PLT. The answer is that all this as PD, as PLT code is doing is giving an alias to the import. Why do we need an alias? Well, when you think about it, the module math only has 4 letters. It's not a lot of typing, it's pretty short. But this module matplotlib.pyplot has about 17 characters. And the thing you'll learn pretty quickly about programmers is that programmers are lazy. And a programmer doesn't want to type out 17 characters every time they're referring to their plot. So instead we wrote import matplotlib.pyplot as PLT. This created a variable called PLT which referenced our matplotlib.pyplot and allowed us to use a short name instead. PLT became the alias for matplotlib.pyplot. And we didn't have to call it PLT, by the way. We could have called it anything we wanted to. We could have called it Jennifer. But you'll pretty quickly discover that there are certain conventions in Python programming, and people like to stick to convention. For example, pandas is usually given the alias PD for some reason. Don't ask me why. So now that we've talked a little bit about this as keyword to create an alias, let's put it into practice so that it really sinks into memory. We're going to use this as keyword with our life module, because we can give that module an arbitrary alias too. Check this out. If we write import life as Hitchhiker's Guide, and hit Shift Enter, then we also have to update this cell below. And the reason is that we can no longer refer to this module as life because, well, we've given it an alias. If we were to reevaluate this entire notebook by going to kernel and going to restart and run all, and scrolling down, we see that we can no longer refer to our module by the name of life. We've given life an alias, so we have to use that alias. We can no longer use the other name, meaning we have to replace this with Hitchhiker's Guide. And if I hit Shift Enter now, this error disappears. The same is true with the cell below. Because our program crashed, these cells were actually never evaluated. If I hit Shift Enter here, again, we get this name error, and we have to replace life dot the answer with Hitchhiker's Guide, the answer. Now our Python code will run without crashing. So I hope this exercise made it a bit more clear as to how this as keyword works in practice. Once we have an alias, we have to use the name of the alias to refer to the module. Now let's take another look at the final import statement from the previous lessons. This import statement read, from sklearn.linearModel import linear regression. And the syntax highlighting here is telling us that this from is also a Python keyword. So without me showing you this in the video right away, can you, as a challenge, structure our life.py module to import the answer using the from keyword? I'll give you a few seconds to pause the video. And here's the solution. The pattern is exactly the same. We would use from life import the answer and hit Shift Enter. Now, a very, very reasonable question that you'll probably want to ask at this point is, how is this different from the other import statements? I mean, why are there 3 ways of importing things? Can't we just keep things simple? And the answer to that is, well, yeah, so the 3 import statements are all doing very, very similar things. And the reason I'm showing you these 3 ways of doing things is because people out there in the wild are using all these 3 ways of writing their own Python code. But there's also a subtle difference with this from keyword. And that difference to the other import statements that we've used so far is that in this case, we're copying out the answer from our life.py file. The answer is now its own variable inside our Jupyter notebook because we've just made a copy of it, and this means we can do stuff with it. For example, we can create another variable and set it equal to the answer. So if I write my favorite number, is equal to the answer, and then print out my favorite number, and hit Shift Enter, it prints out 42. But I can also manipulate the answer itself. So if I write the answer is equal to the answer plus 1, and hit Shift Enter, and then print out the value, we can see that this variable now updated to 43. The value, by the way, inside the .py file is still unchanged, but the copy that we've made inside this notebook has updated to 43. So in summary, the from keyword copies out the answer from our life module, and it makes it accessible as a variable inside our current notebook. And this is different from the other import statements where this doesn't happen. Because if I scroll up and we look at this cell up here, we had to access the answer by writing Hitchhiker's Guide dot the answer. So we had to use this dot notation to get hold of our variable. Now let's compare this from life, import the answer, and my favorite number equals the answer. Let's put this in context of the code that we've written previously. When we were estimating the movie revenues, we had from sklearn import linear regression, and then we set regr to linear regression. In other words, what we did was we copied an object called linear regression over into this notebook, and then because it was too long to type every time, we stored linear regression in a variable with a short name, namely regr. Now, I also want to come full circle. This is a really good point to connect the dots between the lesson on data types, the lesson on collections, and this lesson on modules. Remember when we checked the data type for our regression intercept, and when we read the full name of the data frame? Well, guess what? Looking at the full name of the data types, you can actually see the module name where this data type came from. So for example, the data frame came from the pandas module. And our ND array came from a module called NumPy. In other words, NumPy was the module where this ND array was defined. Okay, so we're slowly coming to the end of this lesson on modules, packages, and imports. And we've covered quite a few important concepts here. So let's review them before we move on. For starters, we learned that Python scripts live inside files ending in .py. And we also saw how we can import existing code as a Python module into our Jupyter Notebook projects using these import statements. We saw that there's a couple of different ways we can import a module. The simplest way being just to write import and then the name of the module. For example, import math. The next level up was using the as keyword in the import statement. So in this case, we import the module, but we create an alias. We create a new name to give the module. And we can use this name to refer to it later on in the code. This is what we did when we wrote import life as Hitchhiker's Guide. Every time we wanted to access the code inside one of these modules, we had the module name, then the dot, and then whatever we wanted to access inside the module. In this case, we had Hitchhiker's Guide dot the answer. And later on, we had math.py. Finally, we saw how we can use the from keyword to copy out a specific piece of code from another module. And this is what we did with from life import the answer. And this is also what we did previously with from sklearn import linear regression. So at this point, you might be asking yourself, why does any of this matter? Why is this a big deal? And I suspect that you're probably already starting to see the power of these import statements and how they're a massive game changer. Because by importing a module, we can use other people's code. And this saves us the work from having to write the code ourselves. In the previous lessons, we accessed the linear regression capability through a module called scikit-learn. We didn't actually have to write the code that implements the specifics of linear regression. All we did was import the functionality and use it. The people who created scikit-learn essentially created a reusable software component. Their linear regression code can be imported and used by everyone around the world for free. So hats off to the authors of scikit-learn. These guys and girls worked their butts off to create the code that we are using every time we import scikit-learn. When we imported our life.py file, well, we only had a single line of code in it. In contrast, check out the code that we imported when we wrote from sklearn import linear regression. This code is actually open source, so you can look at it and read it on github.com. Or you can actually open the .py file itself from the scikit-learn package on your computer. Now, this file alone has about 500 lines of blood, sweat, and tears, and that's just a single .py file inside the sklearn package. In other words, there's loads and loads more files just like this that are part of scikit-learn. I guess the reason that I've climbed onto this soapbox is that I want to get this idea across that we can do all this cool stuff so effortlessly because we're standing on the shoulders of giants. And on that note, let's set the stage for analyzing the effects of drugs on math test scores. And let's import our plotting module, matplotlib, and our linear regression to draw our best fit line. Let's write import matplotlib.pyplot as plt and from sklearn.linear_model import linear regression. And then hit Shift Enter. No need to import pandas, by the way. We've already imported it as part of a previous lesson. So I'll see you in the next tutorial. Upwards and onwards!